This is Geometry, Semester 2. This is a unit called Similarity Review. So we've already been over Similarity. We're going to go over it again. It's number 13. It's the first lesson called Proportional Proportions Practice. All right, it's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find the website. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So I want to try to show you almost every video. I try to show you where those notes are because they are a little bit hard to find, you guys. But hopefully after you find them once, then you can get back to them and find them again. Would be my hope. But so I'll just keep showing this every video if I possibly remember. I do forget sometimes. So this is creatormath.weebly.com. That's the website you're going to. Here's what the home page looks like. It looks like this. That's how you know you're on the right site. And then if you scroll down, you're going to find the words composition book. Everything you need to know about your composition book is on this home page. Here's a picture of it. Here's follow these directions, watch these videos, follow these due dates, and put all these things where they belong in the comp book. As long as you got notes in there, you should have a 90 to 100% on your composition book. Now, for all the video lessons, for the problem sets, for the notes, and for the vocabulary, click the class tab, which we are in Geometry for this one we're doing right now. And notice vocab right here, Vocabulary Geometry Practice Study PDF. Click this and download it to your device, and then Google how do I search a PDF, because that PDF is searchable. If you're not getting 100% on your vocabulary, you don't know that there's an entire list of all vocabulary words we're going to use for the whole year right here, and it's searchable. All right, so go figure that out, please. Now we're going to find the semester that we're in. This is the one semester for this video we're making right now. Now we're going to find the unit. The unit is Similarity Review. There it is right here. Similarity Review. This is the unit. There's 1, 2, 3 lessons in this review. The notes will be here under this tab. The problems will be here, and the video solutions will be here. Okay, when you go to see this, hopefully by the time you get there, this will be done. All right. So the video we're going to make right now. With those notes, which, just so you know, since this is a review, right, we can easily go back to where Similarity showed up before, which is under the first semester. There it is right there. So here's notes on proportional proportion. In fact, I'm going to open these notes. They're going to be a lot like this. So let's just see what these are. Sometimes it takes me twice to open, but these are what would go in your composition book. So they're talking about nested triangles. This is one right triangle nested inside of a larger right triangle. And because they share the same angle here, these two triangles are proportional. So proportional means, you know, like we always break out the model helicopter we got. It looks like this, right? This is a proportional model to the real one. This one is a 1/48 scale. What's this one? I always forget. This one's a 1/43 scale Augusta A109 in U.S. Coast Guard colors. That means if you took every piece of this, every dimension of this, and multiplied it by 43, you'd get back to the actual real shape, right? You'd get back to the real helicopter. So that's what proportional is. It's a scale model. Right, so this smaller right triangle right here is a scale model of this larger one. And so what we know about the two can be used in a proportion. A proportion is one fraction made equal to another. We can talk about these dimensions, which we will in the problem set. These notes will be copied into your comp book. We talk about cross multiplying as a solution. Remember that the 3 dots mean therefore. All right. And notice the vocab which goes in your comp book. Proportional, proportion, the symbol for congruence is here. The symbol for similarity is here. Scale factor, and the symbol for parallel, and 3 dots means therefore, and cross multiplying, etc. Right? Put all that in your comp book. Let's see what the problems are. Let's go straight to it. So, what does congruent mean? Congruent means more than equal. Well, I'd like to say, I'm not sure I really like more than equal. It means multiple aspects of equality. So 3 equals 3 is a single aspect of equality. So we use the word equals between them. But 2 triangles have 3 angles, right? So we have to think about, are the angles, are the corresponding locations, corresponding means same location, different shape, are the corresponding angles the same? And what about the corresponding sides? Are those the same? Right? Corresponding means the ones that match up with the same location in a different shape. And so we're considering multiple aspects of equality when we say congruent. That's why we use the word congruent in geometry, in my opinion. All right, so it's equal corresponding angles and equal corresponding side lengths are equal, right? So what does proportional mean? Proportional is our scale model, the smaller helicopter that looks like the big one, right? It's larger or smaller by a scale factor. It can also be called similar in geometry. We use the word similar. What's the symbol for congruence? An equals with a squiggly on top. What's the symbol for similarity? Just a squiggly. Right? So similar means proportional. Congruence means exactly the same shape, same size. Similarity means exactly the same shape, but different size related by a scale factor. Like our smaller helicopter looks exactly like the real one, it's just smaller. It's a mini-me. If you had a mini-me, it would be a similar human. Similar in a geometry concept, which means proportional. So given the following nested triangles, identify the correct proportions, all right? Well, more than one answer may apply. So here's the smaller right triangle here, right? Here's the larger right triangle here. So let's redraw the smallers here, and let's redraw the larger one here. Okay, so two triangles. And they are proportional because one is nested in the other, so they share this angle. Notice it says same angle. So now we're going to match up. Here's the different things. AB is here, CD is here. Okay, so we're going to set up a proportion which is one fraction made equal to another. AB over CD is here. That's what they give us. Then they say BE over DE. So AB is the large height to the small height, then the large distance over the small distance. So that's good. BE over DE. BE over DE. This is check. All right. So now we're going to do CD over AB. So let's look at CD over AB. So now we're going small to large. So if we go small, DE to BE, DE to BE, then that's good. So this one works too. But just notice, what if we flip this CD over AB, which is what they did here, CD over AB. So we flip this fraction. We must also flip the second. This would be DE over BE. This is acceptable. If you flip both, it still works. So that's another reason why this one works. All right, DE over BE. Let's see that one. DE over BE. So small over large. CD over AB. Small over large. This one works too. All right. And do we flip that? Nope. Let's see. DE over CD. DE over CD. Okay. So small length over small height. Would it be BE over AB? Yes, this one works too. DE over AB. DE over AB. This one gets a little mixed up, but let's do a cross multiply here. DE over AB. So DE over AB equals BE, so BE over CD. So BE over CD. So what we want to do here, let's cross multiply this. Let's try another strategy. This is going to say, therefore, this is DE times CD equals, cross multiply this way, AB times BE. AB times BE. The question is, if we cross multiply anything else, will we get this, right? And what happens is, let's see, we have, no, we don't, this does not look good to me. So we're going to say not this one. We're going to say these choices here. And the reason is, like, look, AB times DE is here. No. CD times BE. CD times C. No. So when we cross multiply these, we do not get this setup. So we're going to go with no to this one, and we're going to go yes with these four. Right? All right, given the nested triangles below, identify the correct proportions. More than one answer may apply. Yeah, Jacob, hang on 1 second. Let's do that. Okay, so this one's got AB over CD equals BE over DE. All right, so here's AB and here's CD. So large over small is BE, large over small. Good, this one's true. Then we got CD over AB. So now small to large, and we're going DE, small to large. This one's good. Notice this one is BE over DE over BE. So we flipped it and is equal to CD over AB. This one's going to be good. And just to show this one's here, right? Now this one just takes it and moves this here, so and flips it, DE over BE. So that's flipped. So if we took this one here and flipped it and said CD over AB, this works too. And that's it right here. DE over BE is equal to CD over AB. All right, let's check this one. DE over CD. DE over CD, so small over small. And does it equal to BE over AB? Yes, this one's good too. We're going to go with this one. And it looks like AB over DE. AB over DE. So height to small. Do we go height? Nope, this one's not going to work. This one's out too, okay? Same thing. So you got these first four we're going to say yes to and no to this last one. All right? It's barely up there. Barely up there. All right, let's try the next. I'll try to get this one completely on. All except the last one. All right, so let's go through it. AB over CD. AB over CD is equal to BE over DE. So that's good. This one's AB over CD is equal to BE over DE. So AB over CD, BE over DE. Good. So we're going to flip CD and AB. So flip it, CD over AB. And flip this one too, DE over BE. This is going to be good too. This one, DE over BE, DE over BE. So small to large. And if we say CD to AB, that's going to be good too. And if we flip this one, DE over CD, DE over CD. So distance to height, is this one going to be BE to AB? This one's good too. AB to CD, AB to CD should equal BE to DE. This is wrong. It should be BE to DE. So this one's out because we must go in that same pattern, right? Well, so this is a review, so we're going a little bit quick, but go back to those original 5 lessons if this is too much, right? And we go a little bit slower on those. But if not, and it's a true review, then hopefully this helps. Make sure you're matching up the title of the video, Geometry Semester 2. This is a 13th unit called Similarity Review with a first lesson called Proportional Proportions Practice, and it's on creatormath.com under the Geometry tab. Hope this helps.